சார் உங்க செல்ல பேசணுமா இப்படியே பேசலாம்?
அப்படியே பேசுங்க.
பேசலாமா? என் பேர் சொல்லணுமா சார்?
ம்.
சொல்லுங்க சார். சார் அப்படியே உங்க செல்ல பேசணுமா இப்படியே பேசலாம்?
அப்படியே பேசுங்க.
என் பேர் சொல்லணுமா சார்? சொல்லுங்க சார்.
இப்போ ப்ரொசீட் பண்ணுங்க. சரி விடுங்க, அது முடிஞ்சு போச்சு. அதை ஒன்றும் பண்ண முடியாது. நாளைக்கு பார்த்துக்கலாம். இல்லை யூடியூப்ல பார்த்துக்கலாம். அடுத்து போகலாமா?
Thank you, sir. So next, I welcome our Associate Director and Professor of Triple Department at the Solomon College of Engineering to present the welcome address for our event. Welcome, sir.
Say good evening to all, one and all present over here. I request all the participants to mute your mic during the session. Coming together is the beginning. Keeping together is progress. Working together is success. A very pleasant evening to one and all present over here. On behalf of Solomon College of Engineering, an autonomous institution at Madurai, it gives me immense pleasure to extend a warm and heartfelt welcome to our chairman, our dynamic executive directors, our principal, my fellow coordinator, our faculty members, and our ever supportive staff members. Your constant encouragement, guidance, and teamwork have made it possible for us to organize and successfully conduct this AICT ATAL Online Faculty Development Program. Without your collective efforts, today's event would not have been a reality. We are truly grateful for your presence and continued support in making this journey impactful and inspiring. I will also extend a warm and heartfelt welcome to all the dignitaries, resource persons, faculty participants, and distinguished guests to this AICT Training and Learning Academy sponsored 6 days online faculty development program on AI-assisted integration of renewable energy sources into EV charging network. This FTP has been designed to provide valuable insights into the integration of artificial intelligence, renewable energy, and electric vehicle charging infrastructure, an area of tremendous importance in today's sustainable energy ecosystem. With a rapid global shift towards green mobility, the role of AI-driven solution in building efficient, reliable, and smart EV charging networks has become more crucial than ever. Today, we are privileged to have with us two eminent speakers who bring with them rich expertise and international experience. The first speaker of today's session, Dr. Sheikh Mohammed Sultan, Deputy Director, Center for Transport Research, University Technology, Brunei, who will be addressing us on electric vehicles and charging infrastructure. His pioneering research and contributions to the transport sector will undoubtedly provide us with valuable perspectives on the global scenario and technological advancement in EV infrastructure. The next speaker of today's session will be Dr. Uma Shankar Subramanian, Professor of Electrical and Electronic Engineering, Amrita School of Engineering, Amrita Vishwa Vidyapeetham, Coimbatore, who will be delivering his session on sustainable smart grid and technology-driven EV charging infrastructure. His expertise in smart grids and renewable integration will guide us in understanding how intelligent technologies can transform EV charging into a more sustainable and scalable model. Tomorrow, we are going to have two more speakers. Mr. K. Karthikeyan, Engineering Team Leader, Caterpillar India Engineering Services Private Limited, will be speaking on AI in energy systems. And the next session will be on AI-assisted vision and energy management system for grid-connected wireless EV charging by Dr. Ravi Kumar Pandey, Associate Professor, Department of Electrical and Electronic Engineering, Amrita University, Kollam. We are indeed fortunate to have such distinguished speakers who will enrich our knowledge and inspire us towards innovation in this emerging domain. I sincerely thank AICT ATAL Academy for sponsoring this FTP and creating such a meaningful platform for academic enrichment and knowledge sharing. Before moving on to the today's session, I would like to share a few instructions for participants. As per the norms, a minimum of 80% attendance is mandatory to be eligible for ATAL certificate. The daily attendance link along with the feedback questionnaire will be shared during each session. The same link will be used for joining all 6 days. A maximum of 100 participants can join through Zoom link. Others may watch the YouTube live streaming because we are live streaming the session in our YouTube channel as well. The same link has been posted in the WhatsApp group. You may subscribe to the channel to receive notification regarding the daily attendance link. For any queries, feel free to contact us for any assistance. We wish you a wonderful and enriching learning experience ahead. Do not disturb during the session. Separate time will be allotted for question answer session. I once again welcome all of you and look forward to an intellectually stimulating and engaging session. Thank you.
Thank you, sir. Next, I welcome our Principal and Professor of EEE and Solomon College of Engineering to present the presidential address of the event. Welcome, ma'am.
A very good evening to one and all present over here. On behalf of Solomon College of Engineering. Madam, is it audible for?
Yes, ma'am. Yes, ma'am. Audible.
Okay. On behalf of Solomon College of Engineering and Department of EEE, with pleasure, I welcome you all for the AICT Training and Learning ATAL Academy sponsored 6-day online development faculty development program on AI-assisted integration of renewable energy sources into EV charging networks, which is going to be held from today to 23/8/2025, this Saturday. This FDP brings together a diverse group of faculty members, researchers, and industry experts from across the globe, all united by a shared interest in cutting technologies that are shaping the future of sustainable transportation and energy systems. We all know nowadays our journey started towards a greener, smarter, and more energy efficient towards our future. The convergence of artificial intelligence, renewable energy, and electric vehicles present an unprecedented opportunities and challenges today. As electric mobility becomes more widespread, the integration of renewable energy into EV charging infrastructure optimized through intelligent AI algorithms becomes not just for the beneficiary, but it is very essential part of our life. This faculty development program aims to equip participants with the theoretical knowledge and also with practical tools needed to understand and contribute to this interdisciplinary domain. Over the next 6 days, definitely you will engage in sessions led by eminent speakers and demonstrations and simulation and testing part, and also interaction sessions which covers various field in the electric vehicles and charging infrastructures, AI techniques, system design and architectures, and renewable integration strategies and storage technologies, simulation and testing part, and also real world case studies and various applications that present in the in convergence with both AI and electric vehicle. I would like to thank AICT and also the ATAL Academy for their continued support and sponsorship of such vital programs. A special note of appreciation goes to the coordinators of our ATAL FDP, Dr. Nagarajan sir, Associate Director, and also Dr. Radha Lakshmi, HOD EEE, for their effort for getting this FDP from sponsorship from AICT ATAL, and also the resource persons for accepting their invitation to deliver their expertise in this FDP. I encourage all participants to make the most of this opportunity, through this which you can learn, you can interact and collaborate and explore new ideas. Let this be not only a learning experience, but also a beginning of new research. You can come with new ideas, innovations, and also academic partnerships. Once again, I extend a warm welcome to all of you. Let us make this program a great success. Thank you and best wishes for an insightful and productive week ahead. Thank you.
Thank you, ma'am. Next, handover session to Mr. Dr. Sheikh Mohammed Sultan, Deputy Director, Center for Transport Research, University of Technology, Brunei, Darussalam. Welcome you, sir. So this is for you.
Okay, thank you very much.
So wait, sir.
Welcome, sir.
Thank you, ma'am. Thank you very much.
Sir, we have make you a host, so you can share your PPT from your lab itself.
Okay, sir. Thank you so much. Thank you.
First of all, I introduce our resource person. So he is working as a deputy director in a Center for Transport Research in Pune, Dar es Salaam. Actually, he had more than 18 years experience in both industrial and academic. And also, he had 25 international journal publication and 55 conference publications, and had 4 patents and published book chapters, 6 book chapters published, and 3 book series also published. And have more expertise in area of power electronics converters, renewable energy, solar powers, and electric vehicles, smart grid, micro grid, and also low voltage DC system. And he had some projects in currently, that is a solar powered electric vehicle charging station, electric vehicle development, and also solar PV system for agriculture and aquaculture applications. Um, so welcome you, sir. So this session hand over to you.
Thank you. Thank you very much. I think that we are going to start 10 minutes ahead of the scheduled time, but that's still fine with me because I am 2 hours 30 minutes ahead of India's time zone. So the time is now 8:50 for me. Once again, good evening to one and all, and I would like to thank Solamalai Engineering College for giving me this opportunity to share some of my experience and knowledge with the wide group of audience. I can see good number of participants have already joined to the session. So without further ado, I will start with my presentation. I will go and open my slides first. Give me a second. I hope you all can see my slides now,
Yes, sir.
right? Okay. Okay. So we will straight away move on with the presentation. So this is the presentation. Myself, Dr. Sheikh Mohammed Sultan. They already introduced myself. I would like to. I am working as a deputy director at Center for Transport Research. Also, I am a faculty member with the background in electrical engineering. Just whenever I go and deliver a session or whenever I introduce myself, people look at me in a way that where is this Brunei Darussalam? So I just always used to introduce myself, and also I prefer to introduce Brunei Darussalam where it is because of different understanding. Some people think that Brunei Darussalam is somewhere in it's one of the Arab country, and it is not actually. So let me move on to the next slide. So Brunei Darussalam, when you look at the slide here, you can see that okay, Brunei Darussalam is somewhere here in between Malaysia and Singapore. So mainly Brunei is sharing its border with some parts of Malaysia, not the mainland of Malaysia, but there are other regions which are called Sabah and Sarawak. Brunei is somewhere in between here at the Southeast Asia, and the picture at the left is the Sultan of the country, His Majesty Sultan Hassan al Bolkiah, and the one just behind him is the Crown Prince. They are the Chancellor and Pro Chancellors of the university, and the lady just behind the Crown Prince is the Minister of Education in Brunei Darussalam. This photograph is from our graduation ceremony. And what you are seeing here is part of our campus from the eagle eye view. Dr. Radhalakshmi already gave an overview, or she just introduced myself. Whatever she said, you can find here in this slide. I'm currently more focusing on electric vehicle charging stations, and also at the same time, I am working on solar PV based applications mainly for the agriculture and aquaculture industry. So today I'm here to talk about electric vehicles and charging technologies. To start with the session, I just would like to interact with you through Mentimeter. So let it open. It takes a while. Please hold on. So to have our session more interactive, I just request everyone to join Menti now. You can either type menti.com here. You can just type menti.com and in your phone or from your PC, it's better to use your mobile phone. I suggest you to use your mobile phone. You just go to menti.com and type this number 1302 and 0122. Obviously, it will take you to my presentation because I have questions here and there for which you can directly answer and we can interact here. This will be more useful. Once you are joined, just click a thumbs up so that I can see that number of people are joining here, please. On the other hand, you can just scan the QR code also to join.
சார்ட்ல போய் தம்பு கொடுக்கும் தம்பு கொடுக்க சொன்னாங்க. அதுல கேட்கணும் சார் நான் பேசுறது.
Shall you go forward? For this time, at least you can respond to me in Zoom now. If you are able to do this, you can join Menti. And if you are joining, you please click a thumb once you join so that I will be able to understand that you are joining, right? Okay, nice. To go forward, because this will come again in all those slides which I am going to show, you can still join from there, right? Because I would like to start with the question. We have 1 hour, 30-minute session and I have a good number of slides. I hope that I will be able to finish it. I will try to cover up whatever I am able to do, right? Okay, great. The slide just starts with the question here. I will go on. So, if you can recognize what is this, you can just, put your answers here. Still, you can join Menti. I already shared the code here. You can use this code, menti.com. If you're able to recognize what is this, you can just respond. You just type your answer. The question will now be available on your phone or on the device which you are using. Just put this one in order to get familiar. If you have any difficulty, just let me know. I think people are still joining. There are only a few has joined. I will move on forward with this slide because actually this slide is mainly made in order to respond here. You can put what if you have some answers, you can put your responses, then we will see the answer. Particularly, this slide is to get familiarized with how to use Menti.
So, okay. பேசலாம் இல்ல இப்ப பேசலாம் ரெஸ்பான்ஸ்
All right. To save time, we will move on with whatever is presented here. Okay. We will just see the answers here to show the response. Okay. That's great. So it's Carl Benz and this is the first car motor. Exactly. So what we are seeing here is, sorry. What we are seeing here is Carl Benz and his Benz. This is the first ever. This is the first ever automobile with internal combustion engine, which was introduced in 1886 by Carl Benz. And now the technology has advanced a lot, and we have come across a long way through the last 2 centuries. And the automobile technology had its own revolution, and it has reshaped or transformed the entire automobile technology itself. What we are having now is the most sophisticated uh, car, we can say. I'm sorry about that. Okay, so we'll quickly move on to next question. Yeah. So these are the types of electric vehicles. When we look at the electric vehicles are mainly classified into three types. I just directly moved into it. Hybrid electric vehicle, plug-in hybrid electric vehicle, and all electric vehicles. Some of you might be definitely knowing more about this one. I'll just go through one by one quickly in order to give an overview of how each electric vehicle looks like. Let me check. Yeah, okay. And I got another question here. When EVs were first introduced, it is a multiple choice question. I would like to have some responses if you are able to answer for this one. I encourage everyone to join Menti. As I said before, if you missed what I mentioned before, you can just type menti.com on the Chrome page, and it will automatically take you to a mobile screen where you can just type this code number 13020122. So that you can join Menti. And if you got answers, you can respond. Otherwise, I can just move on. Okay. Just keep on coming on my screen. Can I have some answers? Like I don't want to talk myself alone for another 1 hour, 30 minutes. It is not going to help, or it will not make any sense. I can see that there are 70 to 80 participants in the session now. And me myself talking alone is not going to be so much interesting, and I don't want to do that really. Right. So I encourage everyone to join. Yeah, there are 67 participants. I just would like a request you to join menti.com and to put some, like to interact, to make this session as more interactive one. Let me move on to the next slide here. So this is the hybrid electric vehicle. As we can see from here, when it is coming for the hybrid electric vehicle, as we all know, or some of you already know very well, that hybrid electric vehicle combines both internal combustion engine, and at the same time it has electric traction motor also. But when we look at the propulsion system, or when we look at the power source from here, we can see that the fuel tank is much more longer than that of the battery here, and it has only fuel filler, which means that the main source of the hybrid electric vehicle is only fuel, which can be either it is petrol, for example, it is petrol. Then when this internal combustion engine is driven, a generator which is coupled to is produce electricity, and that electricity is being stored in the battery storage. So when you look at the combination of hybrid electric vehicle, the power source combination of hybrid electric vehicle, it is usually 75% conventional and 25% electric power, which means 75% is contributed, or 75% or more is being contributed by internal combustion engine, and 20 to 25% is contributed by battery energy storage system. On the other hand, when we look at the plug-in hybrid electric vehicle, as the name suggested here, plug-in, this plug-in itself stands for that the vehicle can be plugged in order to charge the battery in the car. While we are comparing this one with the previous one which is a hybrid electric vehicle, we can see that the size of the fuel, this figure is mainly for illustration purpose only. However, this gives an indication of the contribution of the power source. If you see this one, both the fuel tank and also the battery are of same size, which means in a plug-in hybrid electric vehicle, usually the combination is 50%. Both comes from the, I mean, it is equally contributed by both the internal combustion engine and also by the electric traction motor or electric propulsion system. On the other hand, the battery is independently charged by connecting the vehicle to the charger. Likewise, the internal combustion engine is powered by fuel, so it has both fuel filler and also the charger. The last category or the main category is the all electric battery electric vehicle or pure electric vehicle. We call them BEVs, PEVs or all electric vehicle. When it comes for all electric vehicle, needless to say that all those internal combustion engine related components are being taken out and it has only prime electric traction motor and it is 100% powered by the electric source and it has got only its charger. So there is no contribution of internal combustion engine in case of pure electric vehicle. And according to technical specifications, are the general say confirms that there are more than 2000 small parts in an internal combustion engine vehicle where the electric vehicles are all electric vehicles has hardly 50 to 100 parts in order to build the complete vehicle. That is where the benefits and advantages of electric vehicle comes other than that of the other advantages which we already know. Uh, Can you just please put some answers here? What are the advantages of EVs? Can I have some answers?
Oh, sir, it is environmentally friendly, so
No, you can just, like I just would like you to put them in Menti so that, it will be more interactive. That's what I meant.
sure,
Can
sir.
you post your answers in Menti? Is it possible? May I request others also to respond and those who did not join to join Menti and put your answers, please. Can I have few more responses, at least from those who have already joined Menti? I can see that there are 9 who already joined Menti. At least having 9 responses would be, you know, we will move on with the responses which we have received. It seems there are some, I don't know whether you got some difficulties in joining and responding through Menti. It's okay. So here are the responses which we have received from the participants that contributing to clean air, environmentally friendly, cost is low, lower running cost, emission norms control, no greenhouse gas emission, sustainability. Yeah, so almost all answers are supporting the general advantages which we already know about. Like, yeah, so okay. Right. So thanks to those who have already sent your responses. All are relative and direct answers, as we know. Here are the answers which you have. No greenhouse gas emission, which is contributing to clean air, which is again no greenhouse gas emission. Environment friendly is also related to no greenhouse gas emission. Pollution free, again the same. Sustainability, clean air. Then there are some other general comments which are about economic efficiency, acceleration, cost, low running cost, and low maintenance. Thank you for all your responses. We'll move forward. So we'll just keep this, keep those answers in mind, whatever you put and whatever we have read here. We'll move on further. We need these answers somewhere at the later part of the discussion where I will talk about. We are moving on further to see this is how a battery pack looks like in the electric car. While you look at this one, if you know that, uh, I'm sure that most of you already know how a battery pack looks like in an electric car, but it is very specific that with the conventional batteries which are used in the cars are no more used. I mean, no more used means not used for the propulsion purposes or as a power source in the electric vehicle. In almost all the electric vehicles, batteries are placed on the platform like this, underneath the actual platform of the car, and each of this one, they are all single or individual stacks of battery. So each battery pack can be replaced. When it is coming for the battery bank, each of them are battery packs. And if there is a problem with any one of the battery pack here, one stack can be replaced in order to make things working. And each of them are made with the small voltage batteries. Then they are connected in such a way in order to have a required capacity of the power rating of battery in the car. Right? Can you name some EVs in India, the EVs available in Indian market? Are you able to respond? I just would like to know. Are you able to, are you getting this question on your Menti now? Can someone say, do you see this question in your Menti now? I think this is a simple question I can ask. You can say only yes or no. Can you see this question on Menti? Can you hear
Yes.
me? Hello.
Yes, sir.
Oh, can you hear right? Okay. As there are, are you able to respond to this question here? Otherwise, I just want to skip and move on to avoid wasting time. Right, let me go on my way then. Fine. So here I will just to show some of the EVs available in Indian market. This one is Tata Nexon with a capacity of 30 kilowatt hour battery and 7 kilowatt AC charger, where it has 50 kilowatt DC fast charger. The other one is 68.5 kilowatt battery pack with 11 kilowatt AC charger and 105 kilowatt DC fast charger, which is Hyundai Kona. And the other one in the market, Indian market, is MG ZZ EV, which is having a battery pack of 72.6 kilowatt hour battery pack. It has an onboard charger of 7.4 kilowatt and 94 kilowatt DC charger. These informations also are required for our further discussion. Anyway, I just to keep this slide once again there, we will look into it. These are some samples of the EVs available in Indian market. And now we will further move on into the EV charging. We will just discuss some general overview of the EV charging methods and other types, everything. So EV charging is mainly classified into three, which are wired charging, wireless charging, and also battery swap technology. When it is coming for wired charging, it is known as conductive charging. It is classified into AC and DC charging. When it is coming for the wireless charging, it is further classified into static and dynamic, and the last one is the battery swap technology. The figures below are the representation of all these three type of charging technologies. When it is coming for wired charging again, further under AC charging, it is classified into two. They are single phase onboard slow charging, three phase onboard fast charging. Every term is important here because they all got their own meaning. When it is coming for DC charging, again, it is having off-board fast charging and off-board rapid charging. They are not same. Fast charging and rapid charging are not same. Likewise, single phase onboard slow charging and three phase onboard fast charging are also not same. When it is coming for the wireless charging, it is further classified into three major types. They are near field, medium field, and far field. From the name itself, you can identify or recognize what do they really mean. Where near field and medium field are technologies which currently exist, and far field is considered to be a future technology. So we will look only after this part, some of these parts. When it is coming here for the near field, again it is classified into magnetic field and electric field. Under inductive charging, magnetic resonant charging, capacitive charging, and also magnetic gear charging is coming under the category of rotational magnet type under the medium field. So when it is coming for the wired charging, we can easily see here the difference between the AC and DC charging. This is a general overview, or this picture gives an understanding of how the charging takes place, under AC charging and DC charging. But we will see them in further more detail with the help of this diagram. So the first category is AC charging or onboard charging. What we need to know here is that every electric car has its own onboard charger. Every electric car has its own onboard charger. None of the car come with a charger, and the battery is being obviously monitored and controlled by the battery management system. So when it comes for the onboard or AC charging, when it comes for the onboard or AC charging, what we need to follow here is the red colored line here. You just follow the red colored one. So it is coming from the grid. AC is going to EVSE. EVSE stands for electric vehicle supply equipment. And further it goes to the OBC. OBC is nothing but onboard charger, where the AC to DC conversion takes place. And the high voltage DC is going to the battery pack, which is being controlled and managed by the battery management system. Where apart from the regular flow here, what we are seeing here, there is a pilot wire. Right, we will discuss about the pilot wire at some other later part of the discussion. So it is coming for the AC charging technologies. AC charging technologies are mainly used for this low power, and it is usually slow charging. So the highest charging level, or the level to AC charging level, is of 22 kilowatt among the charges in AC type, which will take 2 to 6 hours respectively. But I don't completely agree with this number also. I will show you some other examples in the later part of the discussion. These are some of the EV chargers. The one you are seeing here is what I have installed in my university, and this is the other one which we have recently installed, which is about to be open for public. But this one we have installed mainly for our research studies. We will see some of the studies which I have conducted in the later part of the discussion. What we are seeing here is from Charge Mode, which is one of the leading charger equipment provider from India, Charge Mode. And This one is a 3.3 kilowatt charger. This one is a 7 kilowatt charger. And I think this is a 50 kilowatt DC charger. The manufacturer is from Kerala. So you can see some figures which are representing Kerala's culture, something like that. Anyway, this one is the typical charging cable connector with EVSC. So charging, when it is coming for the charging levels, there are two different categories, AC charging and DC charging. When it is coming for AC charging, level 1 is slow charging, which is up to 3.5 kilowatt. In India, the maximum allowed low level 1 AC charging is 3.3 kilowatt under single phase. Because when I was showing the categories of electric vehicle charging, under AC charging, you would have noticed that it was single phase onboard charging and three phase onboard charging. Again, single phase onboard charging is a slow charging, which is working with a capacity of 0.3 kilowatt under the voltage of 230 to 240 volt AC. Usually it is not just 8 to 12 plus hours. It will take even sometimes for some cars, it will take 18 to 20 hours for full charge. And it is ideal for charging the cars overnight, and it's mainly useful only in the cases of short daily commutes. Why? Because when you are using this capacity of charger, the amount of charge which is accumulated over the period of a few hours will be very small. So you cannot expect a long range after charging the vehicle. That is why it is said that it is suitable for daily short commutes, and it is going with the standard electrical outlet. What does it mean? This is what we use for charging. This is how typically it looks like. Moreover, whenever we buy a car in modern days, the mobile phones are not with the charger, but every whenever we buy a mobile phone comes with a charger, right? In the same way, whenever we buy a car, obviously we get the charger like this. So this one is a typical 3.3 kilowatt charger with the electric vehicle supply equipment, I can say. It's very straightforward. You just plug it into the household standard electrical outlet. We don't need any specialized equipments to plug in for charging the car. That is how it works. And when it is coming for the cost, it doesn't require any special installation. As I mentioned, it just required only a 3-pin plug point where you can directly connect it. The second one is the level 2 fast AC charging, which is 22 kilowatt. Whatever the charges I have shown you before, these two chargers in my university, both of them are 22 kilowatt. This one is 22 kilowatt charger. This one is a 22 kilowatt dual gun charger actually. Two cars can be charged at a time. This is a single gun charger. So this is connected. This is a three-phase charger. This is a three-phase charger, and usually it takes 6 to 8 hours to charge the car fully, and it is most suitable for workplaces. Mainly, it is suitable for workplaces where people stay longer. They can charge their cars during the time. Also, it is available in most of the public locations. Whenever you are going outside, in malls and other places, you can hardly easily find them. Now, when it is coming for the connectors, it is using Bharat AC001 Type 2 GB by T. We will talk more about these connectors. I have separate slides to discuss about the connectors. When it is coming for the infrastructure, we need a separate, like dedicated charging unit is coming. You cannot, we don't have have one like this one in order to charge. That is not. There is a dedicated charger which need to be installed. So the cost of installation also is moderate at the same time. Since it is charging at 22 kilowatt per hour, charging cost also is higher. That is normal. When we look at these cars, like I just brought the same slide again as I mentioned before. Now, this car has 11 kilowatt AC charger, which is the onboard charger of this car. And when it is coming for this MG has 7.4 kilowatt AC charger. On the other hand, Tata Nexon also has 7 kilowatt AC charger. So in between this 3.3 and 22, there are two other types of charging which are basically 7 kilowatt and 11 kilowatt. Would you like to answer this question, or you just want me to skip the questions and move on to the presentation? If you are willing to put your answers, you can put it. Can a EV with a 7 kilowatt onboard charger be connected to a 22 kilowatt charger? If you want to answer, you please answer here in Menti, because I am not following the chat box actually. So we get mixed response that two responses says that it is possible to connect a 22, connect a 7 kilowatt onboard charger. Yeah, the numbers are increasing on the other side, that they are saying that it is possible to connect a 7 kilowatt car with a 7 kilowatt onboard charger to be connected to 22 kilowatt charger. Let's move on further. Thank you for your answers. We will compare these answers by discussing in the further slides. Thank you. And yes. I think this is an open question. What happens if a car with 11 kilowatt AC charger is connected to a 22 kilowatt level 2 charger? So the answer is, for the previous question, the answer is yes, it is possible to connect a 7 kilowatt car, a car with a 7 kilowatt onboard charger to a 22 kilowatt charger. That is the same thing happens here also. What happens if a car with 11 kilowatt AC charger is connected to a 22 kilowatt level 2 EV charger? What will happen? It's obvious that the car will be charging at 11 kilowatt rating. So now further we are moving on to the DC chargers. When it is coming for the DC chargers, the current maximum capacity available is 400 kilowatt. The charger which you are seeing here, it is Indian, I think it's, yeah, make in India. So it's an Indian made charger. Axon FE is an Indian made charger with the capacity of up to 360 kilowatt. And you can read something here. It is very small, but what is written there is CCS2. Shadomo, GB by T, and Bharat DC001 are the connectors which are used. When it is coming here, the voltage range can go from 200 to 1000 volt DC. Depends on the type of the car which you are connecting. It will take 30 to 60 minutes to charge up to 80% charge. So why it is specifically mentioned here 80% charge is very important. Whatever is the car you are looking at, like whenever you go and read, for example, whenever you go and read the specifications of any electric car, on the electric cars, you will find something interesting, that the charging time which is given here in any car's charging, whenever the charging time is given, the charging time is given only for 20 to 80% charging actually. In most cases, the charging time which is mentioned there is for 20 to 80% charge, which means that 0 to 20% charging and 80 to 100% charging is something different than that of charging a car between 20 to 80% charging. Particularly when a car is connected to a DC charger, 0 to 20% will be slow charging, and then it will charge at its full power from 20 to 80%. Again, when it is going above 80%, it is called as trickle charging. The charging power will be reduced in order to make a power balance. This is the off-board DC charger. As we see here, what is technically happening here is that in the previous case where we have seen this one, this part was not there. I mean, the AC was directly going to the AC to DC charger, then it was taking this way, then it was converted into AC to DC, then the high voltage DC was going here. But here, when you look at this one, it is been bypassed actually. So what is happening here? How this became a fast charging approach? How, in what way we call it as a fast charger, or why DC charging is faster? The limit, because in any car, the onboard charger is nothing but a power electronic converter. As you may all, most of you must be from electrical engineering background, and it has a limitation of having a DC to DC converter, sorry, AC to DC converter in a car. As the capacity of the charger increases, as the capacity of the onboard charger increases, what will happen? Obviously, the size of the power electronic converter will increase. When the size increases, its weight will increase. It will increase the capacity of, it will occupy more space and then it will have more weight. That will affect the entire car, right? By all means. So, it has its own limitation, depends on the size of the car. It can be 7 kilowatt, 11 kilowatt, or maximum of 22 kilowatt. Even the 22 kilowatt charger, onboard charger, can be found only in premium cars. As we are coming back here, offboard charging, how does it happen? When you look at this one, it is not just a single charger, it has multiple stacks actually. So the grid power, AC power, is given to the stack of AC to DC converters, which are already having EVSC plus AC to DC converter, where the conversion takes place outside the car and a very high voltage DC is ready to taken to the battery pack based on the battery pack's capacity. Therefore, it will bypass the AC to DC converter and directly go to the battery pack. This is how high power DC charging is, or this is the reason why DC charging is always higher, faster, or even rapid. I don't want to read out these advantages and disadvantages, which are very general. I will share the slides later from where you can just go through them if you are interested on that. You will see the inductive or wireless charging. When it is coming for inductive charging, currently, like the mobile phones can be even charged by keeping them on a charging pad. Wireless charging is really possible for mobile phones. These days, the modern mobile phones are really coming with the wireless chargers. So the same approach, it has a transmission pad and the receiving pad. The car has to be placed exactly in such a way to position the transmission and receiving pad, and by means of induction, electrical energy is being transmitted through magnetic field to the charger in the car. Then the energy is further converted and used to charge the battery. But there are challenges, like as we all know already, that there are some challenges in using these concepts of inductive charging. When it is coming for the media field charging, so for here, let me check whether I put some numbers here. No. When it is coming for the media field charging, you can see that the charging application with a low power range of 1.5 to 3 kilowatt is only possible. And the chargers can transfer a power of 3 kilowatt over a medium range of 15 centimeters, which means that the distance between these two should be only 15 centimeters. And at the range of 15 centimeter, what is the amount of energy being transferred? It is power being transferred. It is 3 kilowatt. As of late 2009, this was the technology. Over 5 centimeter distance, 1.6 kilowatt power was transmitted with an efficiency of 81%. Whenever it is coming for wireless charging, this is the major challenge or hurdle in using wireless charger. The efficiency is very low, very low, and we cannot really transmit high power through wireless power transmission technologies. Whatever we have seen now before here are the static approaches, and this is what called as dynamic approach. Dynamic approach is, like in UK, they are trying to implement such kind of dynamic approach. What is dynamic approach? Your car will be charged on the go, where the power will be transmitted to the pads which are underneath the road, and the cars will get communicated to the charging pads in order to charge on the go. But what is the thing here? This kind of charging technology have a capability of 3 to 60 kilowatt. It was meant over a distance of 4 to 10 centimeter. You can imagine, like a scale, a short scale is, I mean, that the 15, you can imagine the size of a 15 centimeter scale. The distance is less than 15 centimeter scale, and in 10 centimeter distance only this car can work, or I mean transmit power. But again, when you are coming over here for the wireless power transmission technique, the efficiency of maximum efficiency of 90% is achieved at a distance of 4 centimeter. You can easily, you can check with your hand finger how much is the 4 centimeter distance. So there are practical difficulties, or they are considered to be practically impossible to use such kind of technologies, because l- high amount of energy will be wasted by means of using these approaches, and these approaches are basically not usually advisable or recommended. This is showing all the types of charging methods which we have discussed now. You can, I mean, I collected all those information from this particular paper. The details of the paper also is already given. These informations, whatever the circuits you have seen here are available there, and you can go and read more about this type of charging technologies in detail from this paper if you want. The last method of charging is battery swapping technology. When it is coming for battery swapping technology is one of the simplest approach to charge your car. To charge any car at no time just by replacing the batteries. It's the most efficient method of charging the vehicle. So, is the technology successful? Means yes, of course, because in Taiwan, Gogoro is operating more than 12,000 Go stations, and also there are more than 250 stations in the mainland of China. It is a more successful approach for the two-wheelers, electric scooters. Taiwanese electric scooters are mainly adopting this technology. And when it is coming for the car, only this Chinese car maker Neo has the battery swapping technology, and they build around 1,000 swap stations around China and Europe. These are some of the battery swapping technologies exist in Indian market. Sun Mobility, Sun Mobility is one of the leading battery swapping technology operator in India, and you can find some of the names which are very much familiar to you also, like Ola Electric. Sun Mobility is actually installing their chargers in the petrol stations. I think I don't know whether it was in HP petrol station or Indian Oil or Bharat Petroleum. I am not sure about that, but they are focusing on installing them in the stations. This is the one which is in some part of India which is adopting this battery swapping technology. This is how it looks like. We will just see. I think that, yeah. I will just play this video. I'm going to play a video. You just tell me if the video start playing, okay?
Gogoro, a global technology leader in battery swapping ecosystems, and 917 Ventures have launched Gogoro Smart Scooters and battery swapping in the Philippines. The partnership aims to bring smart, convenient, and accessible two-wheel electric vehicles to Filipino customers while promoting sustainable transportation. With more than 540,000 riders and 1 million smart batteries deployed, Gogoro aims to replicate its success in Taiwan, with public availability in the Philippines is expected by Q4 2023. Horace Luke, founder and CEO of Gogoro, stated, "We look forward to working together to deliver a sustainable transport system that will improve air quality, reduce carbon emissions, and provide a superior riding experience for consumers in the Philippines." Bernie Lamson, Globe Capital Venture Director, added, "The Gogoro ecosystem is very convenient as its swap and go technology allows riders to swap out depleted batteries for charged ones in just seconds and go on their way." Founded in 2011 to rethink urban energy and inspire the world to move through cities in smarter and more sustainable ways, Gogoro leverages the power of innovation to change the way urban energy is distributed and consumed. Shares of Gogoro trade on the NASDAQ under the ticker symbol GGR. For more information, visit greenstocknews.com. Please leave a
So the one which we have just seen is the battery swapping technology, which already exists and which was introduced in Thailand, Philippines, and also in China. This is the representation video from NEO, the one I highlighted for battery swapping for the electric cars. It's a very quick one, so it doesn't give all details, but it is showing that how the batteries can be taken off. Batteries will be taken off, and a new set of batteries will be uh, installed in the car, and the car will take off. So this all will happen in less than 5 minutes, according to experts. Okay. Here is a comparison between different types of the charging approaches in terms of convenience, cost, service time, power level, efficiency, battery lifetime, its impact on the grid, and standardization challenges. So when it is coming for, as I highlighted to you before, if you have a look at this one, the dynamic charging is of course more convenient, but its cost and the impact on the grid, and also the standardization challenges. There are no standards exist. I mean, no proper standards exist in order to implement this one, and it is practically, as I said, practically is really difficult. On the other hand, when we are coming for the battery swap technologies, battery swap technology is one of the cheapest option with the shortest service time. And the power level is also comparatively good, and it is highly efficient method in order to use. And when it is coming for the battery lifetime, it is a smaller battery. So here again, when it is coming for the impact of grid, the impact on the grid will be moderate. We can say that it will be high because number of batteries in a swapping station will be get charged at a time if they are all frequently changed. On the other hand, when we are coming for the conductive charging of both AC and DC, the convenience wise, they are not really convenient because of the time. But on the other hand, DC is becoming more convenient this time. So we can add more smileys here because they are becoming more popular with now the most recent charger is having 400 kilowatt capacity, which will allow you to charge your car in 15 to 20 minutes time. So, but the cost will be high. Service time, of course, it is very short. That's what I just mentioned now. Power level will be definitely very, very high. It is also efficient approach, and there are no challenges because these both are maturity technologies. These are some of the standard comparison between the different types of charging methods which we have seen so far. Now we are moving on to the charging modes. It's a very quick one. When you look at the modes, there are three levels of charging. I just would like to highlight this one. There are three levels of charging. Level 1, which is AC. Level 2, which is also AC. Level 3 is DC. There are three levels of charging and there are four modes of charging. When it is coming for the mode of charging, the first one is the basic method where we use the charger connector to the utility plug. That is a basic charger. It is AC charging and it is a regular household outlet charging. When it is coming for the next level, which is mode 2 is also a household outlet charger, but the basic difference between this one and this one is that it has got its in-cable control and protection, which does not exist in the first method. Mode 1 is not at all safe and it is not recommended to use. So this one is coming with a capacity of 3.7 kilowatt to 7.4 kilowatt. When it is coming for Indian standard, this is 3.3 kilowatt to 7.4 kilowatt. 7 kilowatt or 7.4 kilowatt. Mode 3 is a widely accepted standard for charging, which has a dedicated charger, which is basically called wall box. In most cases, we call them as wall boxes. So the wall boxes are installed for dedicated charging. Again, it can go up to the range of 3.7 kilowatt to 43 kilowatt. But in our cases, in general scenarios, it is up to 22 kilowatt. And the last one is the DC charger, which is the public or commercial charger with a capacity of, it starts from 50 kilowatt and it goes up to 400 kilowatt. So there are three levels of charging and four modes of charging. Connected types is another important factor for everyone to know. And if you looked at whatever I have shown before, this is a very old type of connector, type 1. Type 1 is almost outdated at the moment. And type 2 is the universally used charger connector at the moment. Other one is CCS2. Tesla has its own connector for both AC and DC. So we will not focus on this one. We will just look only after the type 2 Menakis charger and also the CCS2. CCS2 is nothing but combo charging, and Shadamo or GB by T are the protocols which we will see in the next slide. This is type 2 charger is mainly used for level 1, level 2 and for here level 3 AC. When it is coming for level 3 DC, it's not alone the type 2 charger in most cases, because DC cannot be made only with type 2. These are all what the standards which are given in India. These are all Indian standards. Level 1 AC is Bharat AC 001. Level 1 DC is Bharat DC 002. When it is coming for level 2 AC, it uses either type 1, type 2, GB by T or Bharat AC 001. Some of the cars in India are using this GB by T protocol. Actually, it is nothing but the protocol. Let's move on further. This is a pinout diagram, and this is how a charger point looks like in any electric car. This one is from Tesla, but in all types of cars, mostly this is how it looks like. And these are the pin. This is a pinout diagram of type 2 charger. I have specifically taken only type 2 for the reason that type 2 is the universal kind of universal charger at the moment. And when you look at this one, it is a three-phase charger with L1, L2, L3 stands for three-phase and N stands for the neutral, where PE is for the earthing for protection, and also CP and PP stands for control pilot and proximity pilot. We will see what are the, because whenever a car is connected to a charger, these two must happen, otherwise the car charging will not be initiated. when it is coming for CCS, so this is for type 2, what you are seeing here is the combination from here. It will not use this AC. AC is disabled in the other type of charger plug. But however, here what we have, CP, PP, which are the pilots and also the earth. Other than that, it will charge using DC positive and negative. These are the Bharat standards, as I told you before, or as I mentioned before. In India, it is using 3.3 kilowatt, and the chargers are coming with three-phase AC, where each phase is used for 3.3 kilowatt charger. And when it is coming for 415-volt AC, maximum of 15 kilowatt, but now we are using 22 kilowatt charger. As I told you before, in most cases, they are using GB by T protocol. These are some of the charging levels which we have already seen for DC. DC charging levels are again considered level 1, level 2, and the connector type is also given. So have a look at this one. Now, SHADOMO stands for charge they move. The short form of charge they move is what? SHADOMO. SHADOMO is used for Japanese cars actually. Mainly Japanese cars are using SHADOMO. Nissan and other cars like Mitsubishi are using. SAE combo charging station, SAE combo charging system, that is what short for CCS. CCS is mainly used in German made cars actually. Whatever you are seeing here, BMW, Volkswagen, or Garrison, all are coming from, they are all mainly European cars. Supercharger is a dedicated charger for Tesla. GB by T, as I stated, GB by T is a Chinese protocol which is used in Mahindra and Tata Electric cars, which are from India. Right. So when I mentioned, like, let me go back. I have been talking about, let me quickly go back to the slide which we have seen here before this one. In both AC and DC charger, you can find a pilot wire here. Okay. So do you know what is the purpose of this pilot wire? You can unmute your mic and answer if you wish to, or you can type it in your meeting chat box. What is the purpose of this pilot wire here? Protection. Whenever a car is being, I mean, if you have experience already, whenever a car is being connected to the charger, the car will not start charging immediately. It will establish a connection and it will make sure that all the protocols match between each other. After checking all the protections only, the car will establish. It's called handshaking. Basically, it's called handshaking. So the car and the charger will communicate between each other in order to establish a connection. Only if the connection is been properly established, then only the car will start charging. Otherwise, it is so. For that only, the pilot OS are mainly used, and this pilot OS will use different types of protocols. That is what we have seen here in the last slide, which I have just shown to you now. Sorry. So the communication will be established between the charger. This is the purpose of that pilot wire actually here. The pilot wire will communicate with the charger and also the car through the controller area network. For that, so basically GB by T, Shadow are all charging protocols. They are all called as charging protocols. And different companies are using different protocols in their cars. So when we looked at the answers before, like by the time when I asked the advantages of EVs, the answers were most of the answers given were saying that the EVs are really, I mean, emission free, right? Or they reduce carbon dioxide emission whatsoever. The question is that are the electric vehicles really emission free? If you are still in Menti and if you are able to see the question, you can post your answers here. So Mr. Sivananda Kumar said yes, and Mr. Milton said no, and we got some answers here. Professor Kubda is saying yes. Ms. Isra is saying yes, and Pooja is saying yes. That's what I say. If you were to have posted those answers in Menti, it would have been more interactive to see those results on the screen, because I am not showing your chat box. Anyway, it's okay. I think that you are more comfortable in using your meeting chat box rather than using another software. That's fine. So the answer is yes. I mean, the electric, like most of you said yes, and I got some answers no also here. I don't know what are the answers here. We will try to see here the answers. Yeah. So all answers are saying yes. The electric vehicles are emission free. Move on. Thank you for your responses. And I can see a lot of responses which are all saying yes in the Zoom chat box also. Why? I don't know why this is coming. I don't know how I can delete this one on the screen now. Because my eraser is also disabled. It's okay. Yeah, if your answer is no, then I would like to know why, particularly from Mr. Milton and Mr. Gautam. Can you say why it is not emission free? If you want to speak, you can unmute your mic and say
Sir,
something.
good evening, sir. This is Milton, sir.
Yes, please.
Sir, charging the e-vehicle from the grid. So, for the grid, we are getting the power supply from the power station. There, in this power station itself, there will be producing of this emission now, sir.
Thank you. Thank you, Mr. Milton. Great. Thank you so much.
This, okay.
Thank you very much. Let's see. So yeah, I just got the same thing. What Mr. This, I think that this will clarify everything to you. This is our conventional power generation, transmission, and distribution system, as every electrical engineer knows. Or if you are, even if you are a student of first year electrical engineering or second year electrical engineering, you will obviously know what is this one. So what we are basically doing, how do we charge our electric cars is the question now. What we are doing, either we are connecting electric cars to charge from our house, or the electric vehicles are being connected to the electric vehicle charging stations. So when we are looking at the route from here, like what Mr. Like whatever Mr. Milton said, that I am just showing it in a visual form. The electricity is coming all the way from the power station, which is producing electricity using conventional fuels. So technically, instead of emitting the power, instead of emitting from the exhaust of the electric car, we are emitting here. However, the claim is true that electric cars has no direct emission. We can say that electric cars have no direct electric emission. That is the only answer we have with us. At the same time, electric vehicles still emit, But however, comparatively, the emission which is coming from the generating station is lesser than that of what an internal combustion engine can emit. As if you are in the field of automobile engineering, or if you have good knowledge about the cars, you obviously know what is the efficiency of the internal combustion engine. Internal combustion engines are very poor efficiency, so which means the most of the energy is wasted there, and also there is emission. So the fact is that electric vehicles are emission free, with a quote that electric vehicles don't have direct emission. Electric vehicles still emit because they are utilizing electricity which is coming from the grid, where the source is conventional fuel. So here we got the question how we can turn it into a zero emission vehicle, right? Now by having those discussion, you should obviously have the answer for this question, how we can turn it into a zero emission vehicle. And I will just move on further to the next slide. So here the only approach is to reconstruct the grid with the renewable energy solutions. Integration of renewable energy solutions will make it as a completely emission-free approach, or the electric vehicles will become real 100% sustainable mobility when the electric vehicles are charged by using renewable energy sources. Just the remaining slides, I will just quickly show you a case study which we have conducted in my university campus. I don't know who put the marking here, and I am not able to delete them. Give me a second. Okay. So there is one more. This is a solar PV powered charging station which we have installed in the university campus uh, for the purpose of research studies mainly. I started this with the research studies. Now we are using it for other purposes. I mean, we are of course using this only for the research purposes, where we are allowing some people to make use of it to charge their vehicle so that we can get the data. And you can see that it is just installed in my parking lot. Deputy Director of Center for Transport Research. We are using, this is our system. Let me go back to the next slide. This is our system. We are using 10
Oh, sir,
kilowatt solar PV array. Now it
sorry to
is
disturb you.
sorry.
Next speaker joined the session, so try to finish up the session within 5 to 10 minutes.
Yeah, okay. It's done, almost done. Yeah,
Thank you.
sure. Okay. So here, what you are seeing here is the 10 kilowatt PV system with the 20 kilowatt inverter. It is a grid connected grid connected system with the EV charger. And we have conducted some studies in order to understand how the charging will be, charging performance of the car. For that, I have been using this Kia Nero EV, which is having a battery capacity of 68 kilowatt hour charger, and the onboard charger is 7 kilowatt here. Conducted few set of studies where the vehicle is connected for charging at different times for times, and during the generation, what you are seeing in yellow is the PV generation. What we are seeing here in blue color is the charging power. So when it comes for Brunei Darussalam, this is whole Brunei actually. Brunei is a very small country with a total population of 450,000 people, and the longest distance from one end to another end of Brunei is 120 kilometers hardly, right? And when you are going from other part of the city district If you are taking a longest drive, it will be maximum of 177 kilometers. So the maximum distance you may travel in Brunei is approximately 200 kilometers from one end to another end. We conducted some studies. Yeah. We conducted some studies in order to understand the daily travel distance through a survey. We came to know that most percentage of the people are driving only for 25 to 50 kilometer. However, we have taken the worst case scenario to understand this one. Even like the battery capacity of this car, which we have selected, is 64.8 kilowatt hour, and it has a range of 385 kilometer in a single charge. So even under normal driving condition, the mileage range of the car is 75.5 kilowatt hour per 100 kilometer, which means if the car is being driven for 100 kilometer, the energy consumed will be 17.5 kilometer. So for a best case scenario of 125 kilometer per day, energy required will be 21.875 kilowatt hour. With this 10 kilowatt PV system, the average generation is 42.5 kilowatt hour. Therefore, two EVs can be charged in a day. And we have conducted some cost saving analysis. These are the quick slides. I will just skip on. So when it is coming for the conclusions, what the conclusion we derived from our study is that in 1 year, the expected annual saving is 720 Brunei dollar for a residential system, and for a commercial system, it can be up to 6,200 Brunei dollar. Over a period of 25 years, the total billing saving would be $18,000 for residential tariff, but for a commercial tariff, it will be 155,970 Brunei dollar. So the study gave and the concluded that the system is not really suitable in terms of residential consumers, but however, this can be effectively utilized in terms of commercial consumers, and in commercial cases, I think that it is here. Yeah. In commercial cases, the rate of return of investment will be in just 4.6 years. Further, we have concluded that we conducted the environmental assessment study, and it is estimated that 13,185.625 kilogram of carbon dioxide emission can be reduced with the help of this 10 kilowatt system based charging station alone. So this gives the insight of how much electricity we can potentially save when solar PV powered charging solutions are integrated. And this is our publication. I published this paper very recently in a conference, sometimes in May in the conference actually. When it comes for the researchers, I think this is the last slide. When it is coming for researchers in EVs and charging, there is a potential for conducting researches under renewable energy based charging station, charge scheduling of electric vehicles, energy management systems, and there are great potentials to conduct studies on power electronic converters and multi-input converters. Plenty of opportunities are there in doing studies on batteries actually. Battery studies are something really big in the current scenario to do, because you can conduct studies of SOC estimation, battery health SOH estimation, and also the battery technologies also can be studied. Battery management system development can also be conducted as a part of the research studies. And with these things, I have done with my presentation for today. If I mean, since you are just mostly relying on your Zoom platform, question and answer. If you have any questions, you can directly post them there. I will just quickly skip all those other slides. With those things, I am done with my presentation, and thank you very much for everyone for your time and listening to the session. I hope that this session let you to gain some new informations and insights. I posted my email address here. If you would like to discuss anything further in future, you can just talk to me directly over email. I respond to the emails, and I am available in LinkedIn in this name which is given here, and also you can find my Google Scholar using the name which I have given down here. And now, if you have any questions, I would be happy to answer your questions.
Thank you, Dr. Sheikh Mohammed Sultan, for your wonderful presentation for more than 1 hour in this ATAL sponsored FTP. I hope all the participants might have got some insights about the importance of EV vehicle in the near future. Participants, do you have any questions? You can post it in the chat box. We are running short of the time. Therefore, without any delay, I would like to invite the next speaker of the session. Sir, thank you so much for accepting our invitation. Please stop sharing your screen so that I can invite the second speaker to share his slides. Thank you. Dr. Uma Shankar Subramaniam, are you there, sir? I have given you the co-host privilege. And before moving on to the next session, it is mandatory to capture a few moments of ATAL sessions. Therefore, I request all the participants to switch on your camera so that I can take a virtual group photo, which will be useful for our documentation purpose. I request all the participants to switch on your camera. Oh. Video disabled இருக்கு. இப்ப அது வீடியோ எனேபிள் பண்ணி விடுங்கப்பா. Now I have given you the permission to switch on your videos. Please switch on your videos. Quickly switch on your video to capture the moment.
Good evening, sir.
Good evening to all.
Good evening, sir.
Good evening. Good evening. So thank you. Without further delay, we'll move on to the next session. Uma Shankar sir, you can share your PPT. We'll start the session by giving small intro about the speaker of the session. Yes, proceed. Don't worry, we will share the slide end of the 6th day. We are having the PPTs of all the speakers. You need not worry about all those things. So last day, we will be sharing the Google Drive link of all the PPTs of the resource person.
Thank you so much, sir. Thank you so much.
And don't repeatedly asking attendance link. We will randomly post it in the chat box. The moment you get the link, you can give your attendance, right? Thank you so much.
Okay.
Proceed.
Good evening, sir. So some small introduction about next resource person, Dr. Uma Shankar and Uma Shankar Subramanian, sir. Actually, he working as a professor of EEE department, Amrita School of Engineering, Amrita Viswa Vidyapidam, Coimbatore. Actually, he was worked as a professor in Renewable Energy Lab, College of Engineering, Prince Sultan University, Riyadh, Saudi Arabia. And also he had more than 20 years of teaching experience and act as a leadership and research, industrial and R&D experience in renewable and electrical drives. He also part of a chairperson and also editor committee member in Elsevier, Springer and IEEE and ITES, Believe and other high impact journals. And he is a proud alumni of GCT and also outstanding alumni of VIT in a 2002 batch. Welcome, sir.
Thank you, ma'am.
Thank you, Manoj. Thank you, sir.
Professor, thank you so much for this invitation. I think let me start my session.
Yeah, sure. You can proceed, Professor.
So I would like to discuss something related to sustainable smart grid and technology-driven EV charging infrastructure. Whereas if you look at the current trend, I hope so most of you aware of electric vehicles are booming, and especially in the two-wheeler as well as four-wheeler categories, light vehicles. So in this scenario, so what's really happening at present, and how we can make it as a sustainable one, especially the EV charging infrastructure, is my topic of today's discussion. So why we are jumping from gasoline or petrol diesel based vehicles to electric vehicles? So we have so many forces. I can say something related to domestic policy, and some of them related to the global impact, especially the climate change related issues, where every country they have their own target. And another thing is like most of the Western countries, they want independence from the oil. So that's the reason they are jumping from the fossil fuel to the electric vehicles. But are we really using the electric vehicle? Is it clean nowadays? Like whatever we are using in our day-to-day life in India? No, it's not so. The reason being that is where we are getting this power for this charging station is most of the power is from the conventional power plants, thermal power plants, or you can say that it is the conventional power plants. So if this is the case, it's not really so clean. So if this is the case, so we cannot call this as a green charging, or I cannot say that it is pollution-free charging. So still there is a pollution is involved. So that's the reason. So we have to jump from this pollution-based charging to a complete pollution-free charging. So if you look at the statistics, for example, since from the 2014 and now we are at 2025, this is a projected one. It is not the actual one. So based on this projection, if you see that by this time we should have 75% of the vehicle should be battery electric vehicle, and only the 25% should be IC engine based vehicle. But it's not so. Actually, this projection or this target is not achieved as of now. Yes. I hope all of you can hear me.
Yes, Professor. You can proceed.
Okay.
Yes, sir.
So what we are focusing now, for example, so either we are focusing on battery technology or we are focusing on EV charging technology. So in EV charging itself, there is a couple of different categories are there. For example, slow charging and medium charging and fast charging. As you know very well, the slow charging is for the case of like if you park your car for a long time, you can use a slow charging technology. Whereas whenever you are going for any like a mall or a hypermarket, or if you're going to the office, then you can go ahead with the medium charging. And wherever you are traveling, especially from one place to another place, it's a commuting. So during that time, I think you can look at the fast charging technology. In case of a EV charging technology, ABB is the pioneer one, and they have
Professor, unmute yourself.
Okay. Thank you.
Awesome.
So if you look at a different fleet, especially industrial, you can look at it. So for each and everything, they have their solution, including for the roadside station or public commercial or apartment, or especially for the residence applications also. So if this is the case, so so what we are looking at exactly. Why the slide is not moving? Okay. So these are the different cases, like they have the solutions for the charging technology, especially if you look at starting from 24 kilowatt to 600 kilowatt, you can say from slow charging to the very fast charging technologies. So for example, some cases you can use it for the residence application, and some charging products you can use it for the commuting application, and some charging technology you can use it for the office application or any other commercial applications. As far as the charging standards are concerned at 900 kilowatt level, so the China is the leading one, and they have this new GBT technology, which is something around 900 kilowatt. And if you look at that, they are the one they are leading, and they are also satisfying the IEC standards as well. So comparing the Chinese technology, you also have other GBT charging, CHEDMO or CCS, or you can see the Tesla also. They are also in this product portfolio. So, as far as the fast EV charging is concerned, the ABB is the leading one, and they have already installed this flash charging stations in abroad, especially in the Europe. So the same technology, if you see that they had a tie-up with Ashok Leyland, which is in Chennai, and they have set up this flash charging technology in Chennai itself, I think in tie-up with the IIT Madras. So you can have one video so that you can just look at how the fast charging technology is.
Do you think charging in 20 seconds is possible? Well, it's possible. After watching this video, you will say this. Recently, Indian automaker Ashok Leyland and Switzerland ABB Power Products signed an MOU to provide flash charge technology to Ashok Leyland electric buses. Earlier, Ashok Leyland tied up with Sun Mobility for battery swapping technology, and the swapping time of Ashok Leyland electric bus in Sun Mobility swapping station is 2.5 minutes. But with the ABB Power flash charging technology, the batteries can be charged in just 20 seconds. So, let's understand the flash charging technology now. ABB Power has developed trolley bus optimization, system alimentation, TOSA charging stations to recharge an electric bus battery in just 20 seconds. In the charging time, passengers can get on and off the bus. So, let's see how it works now. The electric bus batteries are mounted on the rooftop. Once the bus reaches to TOSA charging station, an automated arm will connect an ultra-fast charger to the energy transfer system on the bus rooftop in 1 second. These chargers having 600 kilowatt of power, which can charge the onboard batteries in 20 seconds. That's why the technology is called as flash charging. The TOSA charging stations are connected with a grid connection along with an energy storage unit. The entire charging process is controlled by traction converters and traction motors, which are equipped in the bus. Currently, there are 12 such buses operating in Geneva. For 50 bus stops, 13 are equipped with flash charging stations. These flash charging stations providing emission-free urban transportation. Due to the flash charging, 1,000 tons of CO2 saved on Geneva line per year. Also, the buses having 133 passengers capacity. So, Ashok Leyland along with ABB Tosh flash charging technology will take public e-mobility services to the next level for sure. Once the ultra-fast charging services started in India, pollution levels will be reduced and the trust in EVs will be increased. We can see the flash charging electric buses on Indian roads very soon. Go green, go electric.
Hope you might have seen the video. I think they have clearly explained about how it benefits in terms of to achieve the sustainable development goal as well as to mitigate the climate change related issues. The next one is about the wireless power transfer because this technology is not new. I hope most of you might have aware of it, and this technology is currently used in the mobile phones. And as far as the wireless power transfer is concerned, it is the basic electrical thing, which is nothing but inductive or capacitive charging. As far as the inductive and capacitive charging is concerned, so you need to operate those converters or the power electronics in one particular frequency, operating frequency. So basically, it is nothing but a high voltage and high frequency operation. So there are different kinds of charging locations based on where you are parking or suppose if you are parking in your home or if you are parking in the office or even in Europe, they started what to say like dynamic charging, the vehicle in motion. So these are some of the pictures which is directly explains you like how the WPT parking infrastructure in the static location, as well as the one you can see in the right side is the dynamic motion. So this is under the test and development stage, the one in the right side, and the one in the left side is already in place. This is the one I hope you might be knowing during the COVID time. They have started installing this India's first public EV charging plaza. So you can see that how they are allocating the parking place for the EVs. This is the one I think most of you might have come across when you are traveling from one place to another place, especially in the highways. So this is the company which is which they have installed a lot of electric vehicle charging station, but not at the higher level, approximately at 50 kilowatt level. So maximum you can charge 2 cars at a time, so that so you can easily charge it when you are traveling from one place to another place. So as far as the wireless power transfer is concerned, so it's none other than two conductors in place. And this has an electromagnetic field which is transferring the energy from one plate to the another plate. Whereas inside the car, you might be knowing there is a inbuilt power electronics. So this will be taking care of charging the battery, as well as whenever it is charged, the same battery could be used as a source for driving the electric vehicle. As far as the wireless is concerned, so there are a lot of vendors or the manufacturers, they already had this kind of wireless charging in place. For example, like a Volvo or Infinity, they have this plugless power already. But when you talk about who is leading this particular EV wireless charging is nothing but Vitricity, which is one of the company which is from US. But even though it is a US company, they have this technology, but most of the implementation took place in China. So that's the reason if you look at China at present, they are leading in this particular technology and they are the leading supplier of the EV charging stations as well. So let us see another video which clearly explains how the wireless charging is taking place and how it manages for the different cars. As far as the charging infrastructure is concerned, as of now, you might be knowing, or all of you might be knowing. So they are most of the places they are not using any sustainable energy technologies. Instead of that, most of the power grid only they are utilizing it. But in fact, the original architecture should be like this. So it should have some smart grid power management, and it should have provision for connecting the renewables, as well as in case of renewable is not available because it is intermittent in nature. So you can just go ahead with the power grid. This is same for the office premises also. So you can see how they are utilizing this solar PV technology along with the battery energy storage, also the grid. So this is the basic structure usually should be adopted all throughout the India. Since I'm unable to know or in detail about this commercializing technology available in India. Even the parquet structures, I think you might have seen in some of the industries or some of the hypermarket or malls, you might have seen. So they have this facility so that you no need to search for the extra place for placing these solar panels. Instead of that, you can place it in the parquet structures. So when we talk about this particular technology, so which is very popular in this EV market is especially the battery and the battery charger. This is a very much popular. So it's not only for the two-wheeler or three-wheeler or four-wheeler, but also the same batteries are refurbished batteries or reusable batteries. You can use it for the energy storage applications as well. So when we talk about this business, especially number of EV charging stations, the percentage of slow charger or fast charger or something like that, so which is very dominating and which is a promising one. And you can look at the projection also. So when you look at 2026, so what is going to happen? So that could be like a multifold in this number of EV charging stations, especially the slow chargers as well as the number of fast chargers. As far as the Indian scenario is concerned, so there is a lot of schemes available in India. For example, National Electric Mobility Mission Plan, as well as the faster adoption and manufacturing of hybrid and electric vehicles. So under this schemes, if you look at it, so there are a lot of developments are happening, especially some of the entities. When you look at private as well as the public entities, also they are participating in this. But there is a couple of challenges as well as we need to understand about the regulations as well. So these are the challenges as well as the regulations. So I hope this is very clear to you all, and maybe most of you are aware of these challenges, especially for the Indian scenario. So when we talk about two-wheelers and three-wheelers, private vehicles, commercial vehicles and buses, so what we initially used, that means a short term, what we used, and long term or medium term, what is going to happen in the future. So wherever you are using a battery swapping technology, I think you are going to replace with the personalized charging facility or a public charging facility. Battery swapping is, if you look at it, I think it is more suitable for the three-wheelers as well as for the four-wheelers. But even for the four-wheelers, for the long-term point of view, it may not be feasible. That's the reason. So they have suggested the public charging is the only solution. So that's the reason if you look at most of the petrol or diesel stations or the bunks, which is managed by different public companies. So they are also invited to convert their petrol bunks into equalized charging stations. But I'm not sure about whether they are going to use the sustainable EV charging station by using the solar or battery energy storage or wind. So once upon a time, if you look at it, so CEO of Schneider Electric, Mr. Jean Pascal, so he given one equation, which is nothing but the world in the next 40 years would require more energy, but in ever more sustainable way. So in the next 40 years, if you look at it, the energy consumption may be double, but here they given only approximate. I think when we look at the development and technology development, I think it may not be double, it might be 4 times. And at the same time, you need to reduce the CO2 emissions by half. If you want to achieve these two objectives, so what is the constraint is you should have a electrical system should be 4 times more energy efficient. That's the reason nowadays when you go for any, when you purchase any electrical equipment, you can see that what is the energy consumption rate, either in terms of power level or either in terms of star level, 2-star rating or 3-star rating, like that. So that's the reason nowadays they are mandating this policies to be incorporated in the whenever you are purchasing the electrical equipments. So whenever you look at the grid side, especially the grid is nothing but what the grid is nothing but mostly from one way. Okay, there is no two-way electricity grids. So this is something called one-way energy only grid, but you have to make this as a two-way data and energy smart grid. So what are the key drivers are there? For example, growing electricity demand, it is like growing like anything. At the same time, you need to focus on reducing how to reduce the CO2 emissions. Along with these two, if you look at it, you also have a constraints on existing electrical networks. For example, you need to restructure the electrical infrastructure networks. And who is going to be the main contributor is nothing but it is a technology availability or active government and regulators, active end users. If all satisfied, for example, if you are taking care of key drivers and if you are taking care of the main contribution, then I think you can achieve this microgrid should be happen. So here, if you look at it, this is nothing but the conventional way of energy only grid, where you can see a centralized generation station, which is somewhat far away from your distribution center or the load center. And when you look at this, so you also have like a distribution side, also have a consumer side. So how the electricity travels from one place to the another place, where you can look at it.
Please provide a complete question.
So you can see the arrow, so how it is traveling from the left to right. But if you want to convert to a data smart grid, two-way data smart grids, you should also have a renewable energy plans in the generation side. You also have some distributed generation plans in both the distribution as well as in the consumer side. Why you need this, especially when your electric vehicles are growing like anything, and there is also the equal amount of electricity demand. That's the reason. So you should make exposure or just teach the consumers so that they can get this experience and they also aware of it. So, and they also can participate in this particular two-way data smart grid conversion. So this is nothing but you are making the consumer more actively involved in this particular process. If you make them actively involved, so there is a possibility that you can charge your electric vehicles in your home as well as in the office premise. And you also have the communication and software protocols so that you can make the grid smart. How you can make the grid smart so that you can utilize this utility network and you can directly give to the consumer to make them aware of whether the utility is available or what is the price of the utility. So like based on the time to time, you can the consumer may aware that what is the price he's going to pay for this charging his electric vehicle or using the electrical equipments inside his home or office premise. So this is what going to happen in the future. I think even the central government, they already adopted this scheme. I think they started some trial run. So what is going to happen is how you can make this microgrid to be like a smart or more data friendly or dual. You are making the energy producer as well as the distribution network operator, energy supplier, or energy traders and aggregator. So you are actively participating each and every one of this particular side, especially from generation, distribution, and consumer side, so that you can easily make the grid as a smart. Okay, it's not only microgrid, but make the grid as a smart. So if you look at different entities, especially when you talk about the buildings or when you talk about the residential application, so how you can make generation more smart, okay? Whereas you have seen the smart grid in the previous slide. So how you can make the generation more smart is how you can smartly integrate or interconnect the renewables safely and efficiently into the existing grid, okay? This is going to be the huge challenge because the existing infrastructure is also is a weak point. So that's the reason if you look at it, so we need to focus on all these things. And also we are depending on the technology. For example, artificial intelligence or IoT, or if you see the smart metering things, then you are also focusing on data analytics. So all these things are coming into picture. So finally, so which is going to give your grid more smart, and how you can make this smart grid to happen. For example, you can see here, by making efficient homes, including the EV charging infrastructure, and you can make more efficient enterprise, especially the buildings and industries and data centers, plus EV charging infrastructures, so that you can make the smarter demand plus smarter supply by using the flexible distribution as well as the smart generation, so that all the participants, okay, they'll be involved in this, and you can have a proper demand response. So if the demand response is proper, I think you can make the smart grid to happen. So this is what the ultimate equation. So who are the entities going to involve in this is very important. Some of the projects what we worked in the previous, like a couple of years back, tie up with the National Institute of Wind Energy. For example, you might be knowing most of the wind turbines are like installed in 1990s or 1980s. Okay, if this is the case, how you can utilize these old wind turbines? Because most of the wind turbine owners, what they feel is they got their money back, so they don't care about maintaining this wind turbine. So what happened is, like, because of these issues, there is a lot of power quality issues rise, especially in the substation of Tamil Nadu government. So if this is the case, so what they did is we also participated in this, and as a part of this team, we suggested 75 kilowatt PV along with battery energy storage. I think you guys might be knowing now it is in operation in Center for Wind Energy and Technology, I think research station in Kaita. This is one of the particular setup. So you can see that how you are going to make the existing grid more renewable based and make it more smart by using his smart grid controllers. Likewise, we need to change in each and every place where you have this existing infrastructure. This is a general idea for the university or the college. You can follow, like what kind of energy storage you can incorporate in your college as a smart grid lab. So you can utilize different inverters. So you're not going to use any centralized inverter. Okay, so it's a string inverter, which is put together is coming around 1 kilowatt. And you can have a smart meter, or you can say net metering, so that you can easily measure how much you are generating from the PV and how much you are getting from the power grid. Along with this, you can also have a domestic power generation inside your lab, like micro PV level. Then all these systems could be connected to the SCADA, so that you can easily have an interface, so that you can easily monitor the data. And later on, you can use it for research purpose, for example, prediction, condition monitoring, etc. This is the another one where you can see the future flights. It's going to be like completely renewable or hydrogen based. So most of the hydrogen, if you see that how they are generating the hydrogen is nothing but it will be generated from the renewables only. Whenever there is a excess renewables, so that that means renewable energy is available. Instead of giving to the consumer, you can convert this renewable energy to store the hydrogen or generate the hydrogen, and you can just dump it in the containers, so that hydrogen storage can be taking place, so that hydrogen will be later on will be used as a fuel for the flights. Not only for the flights, I think you can also nowadays use it for four-wheelers. I think the government has already formed a hydrogen forum. I think our Honorable Minister Nitin Gadkari, so he already introduced this, especially for the four-wheelers, taxis. So I think I have quickly completed at a very fast thing. And if you have any clarification or doubts, you are always welcome to ask. Any doubts in this?
Participants, any discussion?
If there is no doubt, can we wind up the session now?
Okay, sir. Thank you, sir. Thank you so much for your wonderful presentation. Participants, any feedback, any discussion about fee and the session? Anything you want? Please share with our resource person, Uma Sangha sir, Dr. Uma Sangha sir, please. Anything, please, please share with our resource person. Okay, sir. Sir, thank you, sir. Thank you so much for your wonderful presentation.
Thank you, ma'am.
Thank you, sir. Thank you, sir. Participants, please wait. Continue in the link. I will share the feedback link. From this feedback link, I finalize the attendance. So please wait in the link. Thank you, sir. Thank you so much, sir.
Thank you, ma'am.
Thank you, sir. Participants, please turn on your video. Want to take a photo shot? Please turn on your video. Thank you. One second, sir. Thank you. Now I will share the feedback link. Please, all of you fill this feedback form. From this feedback form, the attendance will be marked. Please stay on the link.
Madam, still session is going on, it's over.
So waiting for feedback, sir. Waiting for feedback only.
Ma'am, if you are completed the feedback,
Yes.
can you leave?
Yes, sir. Can you leave, sir? Leave, sir.
Thank you.
Okay, thank you, sir. Tomorrow we will join at 6 p.m. sir, sharply. Thank you, sir. Thank you so much, participants, sir, to all.